Okay, here we are. Let's see. I've been a part of OWASP for many years, I think back to 2008. And it's a wonderful community. I think everyone here is involved for a variety of reasons, from being part of the membership, from being part of the meetups, the talks. But I do encourage you to get involved more with projects with the community because it will only help you in your career and expose you to a lot of great ideas. And so today I'm going to talk about a few different things. So the talk title, inSecurity is Eating the World. This is kind of a riff on what Mark Andreessen said in 2011 of software is eating the world. And I don't disagree with him. Software is eating the world. But as we see that going with software eating the world, the unfortunate thing behind that is that security is eating it as well, or inSecurity. And we really have a lot to do, I think, as everyone knows. Is anyone here not getting enough work? I think we're all quite busy in what we need to do. And so what I want to talk about is a little bit about what I've observed throughout my career and some of the roles I've been in. I've been in the information security space in various roles for about 15 years now and have seen a lot of different things from a lot of different perspectives. One of the exciting things is I've had a chance to work with a lot of amazing people, actually several of which are here in the audience, which is a really interesting thing about the security community. You just don't get away from people, for good or for better or worse. But it's been really great. And you know, going back to the very beginning, my career started actually in pen testing and in red team engagements. And one of the exciting aspects of that was not only the technical challenges of breaking into a bank or government system, but also the social engineering on the phone, in person. And the fact that my first role, I was being trained like, all right, you're gonna call up these people and you're gonna convince them to give you your password, their password over the phone. Like, why would anyone do that? And lo and behold, as you start to work through different scenarios, about half the time we would get the password from someone over the phone, a random phone call. And what was interesting and kind of unlocked in my mind about that was the combination of the technical work that we did for security, but then the human element. And I think that's really powerful as you start to think about this. Technology is a part of life, and life is humans. So while we're trying to secure technology, we're still securing humans. And if you disregard that human element, a lot of things fall apart real quickly. So across my time, I've spent time in red teams. I've spent times in defense at a global, a Fortune 500 company doing defense of the company. I've spent time focusing on application security, reading lines of code, testing governments, testing telecoms, and also building security programs for companies like Mozilla and Twitter. And like I said, I think where you are in security, you have a very different vantage point on what are the biggest issues. If you are on the offensive side, you might say, man, you guys really don't know what you're doing. How could you have a cross-site scripting issue? It's so easy. You just outputting code, like end of story. Well, sure, it's technically very simple. But on the flip side, doing that at massive scale inside of a company that's doing continuous deployments all day with developers all around the world, that's a little harder. And so you really start to put it all together and say, oh, this is why security is so challenging. So let's dive in. We've all been interested in AppSec for many years, and it's maybe years ago was a niche, and we fought for spending against the network security, networking groups and operating systems. But now, technology being everywhere, technology run by applications, software is everywhere. And so there's some interesting things you can look at where how prevalent is software in our lives? And so you start to look at the lines of code in different major things that exist around us. So the Hubble Space Telescope, 2 million lines of code. Average drone has about 3.5 million lines. Boeing 787, 6.5 million. Even cars, of course, this is from a few years ago, but the Chevy Volt, 10 million lines of code. And I am no expert on car security. I have worked with some of the best in the world. And it's amazing the types of things we have to think about for the security of cars. And of course, the Large Hadron Collider, there we go, 50 million lines of code. But I think as we look at this, there's just no question that every single thing we do in the world has software involved in one way or another. So this is no longer a fight of operating system security or network security. It's code all the way down. And until we figure out how to secure code everywhere, we're going to have some real challenges in front of us. Our homes are connected, the cities are connected. Where would you go in a few years if the software powering cars, powering Lyft, powering Uber doesn't work, suddenly everything starts to grind to a halt. So technology runs our lives, software runs technology. So today I want to talk about two big elements that I've observed. And this ties together through the idea of how do we scale our security efforts. Because I don't need to do a slide anymore of breaches. Maybe 5 years ago, maybe 10 years ago, you start with big breaches in the news. But you guys read the news today or yesterday. There's breaches on the front page of the news every single day. So it's no longer an issue of saying, this bad thing happened, don't let it happen to you. We know those are happening all the time. But instead of being security nihilist, instead of saying the sky is falling, what do we actually have to do better? And there's two big parts of this that I want to touch on, which is how do we look at consumers and the security that they face? How do we interact with them, and where have we been doing that incorrectly? And we'll talk about scaling that through usability. And then on the flip side, what about our enterprises? So we need the end users to be doing the right things for security. But as we defend our networks, as we defend our applications, as fundamentally we defend the data, how do we change that line of thinking? Because again, back to every day of the news, it certainly isn't working with the status quo. So let's think about security for the consumer. And we could dive into the technical elements of this, but before we start to talk about that, since technology is a part of our life, let's pull back and think about it from a different perspective. When you get into your car, you have a lot of safety features. You have anti-lock brakes, you have airbags, you have seat belts. How many of those things do you tune or turn on when you buy the car, or ask if you're sure you want to use them? None of them. Those all work by default. They're what you get, they're required. And how often do you get a warning message saying, there's not a secure communication to blah, are you sure you want to turn on your car? Never. I mean, can you imagine what that would be like? I mean, even you guys, I think we'd all take a picture, we'd share it on Twitter, thanks. But can you imagine any of your relatives getting some warning message before they turn on their car? Like, I don't know. The check engine light is on, like, panic. And so as we look at how we interact in the day-to-day world around us, in any fashion of use of technology, it just works. And there is no asking you, the user, are you sure you want to board this airplane? It's only operating at 80%. Like, no. It's secure, it works, end of story. And as we think about that reality of what our users expect, we're definitely not in that mindset for technology. We're kind of taking the other approach, the approach that makes sense to us. Like if we were going to something, we would want to know everything because this is our specialty. We want to know all the details. We're not using the right, which encryption algorithms are we using? I don't know if I like that one. Let's decline, let's choose this one. It's cool, it's interesting to us, but it fails miserably for the rest of the world. And I don't think there's any question that this isn't really working. So we, ourselves, experts, said we have created secure communication. There's no reason anyone in the world would ever be able to monitor what you email to each other because PGP. How many people sent an email this morning using PGP? I don't believe you. And we're the security experts, and we don't even use it. It's just not feasible. I did Google for introduction to PGP, and it's great. Somebody did publish it, and kudos to them as a professor. Introduction to PGP for beginners in 14 small steps. It's like, ooh, buddy. Okay, so we started out there. We created something that was academically secure. On paper, it's great. It holds up. You can't break into it. But practically speaking, nobody uses it. So did we achieve security? Not really. Well, what about authentication? Have we done that? We have secure authentication. People pick a very strong password with, let's see here, no less than 8 characters, memorized, written down, it must be secure. I'm not actually sure what that means. And it contains some of these characters, and it also has to be private. Again, I'm not sure what that means. Do we have secure authentication? Are people getting accounts taken over? Right, no, we don't. And so maybe again on paper this holds up to nice mathematics of brute force combined with throttling and correct password storage depending on your threats. but practically speaking, it means nothing to our users. It's a total free-for-all. And even across different sites, of course, we give different advice. So this is something that is not new. We all beat on these types of things all the day, all time when you see it on the internet. This is, ridiculous. Now, I'd like to pose a bit of a thought exercise here. What about this? What do we think about this? The Internet Password Logbook. What do we think about it now? So this is a really interesting activity, and I actually think this is a really good interview question, which I guess I'm giving the answer to. But I think this discussion opens up a lot of interesting perspectives on how you look at security. So I was reading through the reviews of this because this password book is highly reviewed, 178, 4.5 stars. I think it's got the market cornered on internet password books. And so there's some interesting things in there, and it looks like you can see that text. So one person, I love this little thing. I finally have a place for all those dang passwords that you're supposed to keep different. Hey, look at that. Some of that awareness is carrying through. This person knows different passwords for different sites. Excellent format. This one only has a single line for entering. Most books have a single line for entering passwords, but this one, they change their password from time to time and they can record the changes. Hey, they're actually changing the passwords. Which, interesting side note, go back 5, 10 years. We remember everybody change your passwords every 90 days. Everybody would groan. We'd all say you have to do that. If we stop to think about why do we actually recommend that? And maybe you can come up with some reason, but actually it's not a good recommendation anymore. And in fact, NIST in their latest release said, don't do that anymore. It's a bad recommendation. And I think this is pointing to where we're going, which is, why are we doing the things we're doing? What is the usability impact, and is it really worth it? So continuing on the reviews, the notebook does as it is advertised to. That's great. A notebook that doesn't fulfill its promise of advertised is concerning, but as I say, I always have to reset my passwords since I forget them for sites I rarely log on to. The reason I picked this is, again, as we think about usability, we have an intended path of how our controls work. People log in with their strong passwords, and the strength of the authentication is based on that strong password or the multi-factors. But here we have somebody pointing out something very correct, which is, what if you just forget the password? You do a forget password flow. And then suddenly we're demoted to the weakest link of security, which is the security of the email account associated with the primary account. And so if that password is 1234, what does it matter? And that's a very common attack technique. Go and attack a bunch of email addresses, do password resets, go and log into all those sites. Actually, I believe, someone will correct me if I'm wrong, I believe Yahoo let you recycle unused email accounts. Looking for anyone to nod, yes, maybe, a few years ago. And the problem they had was somebody signed up with an account, and lo and behold, it was mapped to that address. Somebody new took it, and the password reset flow would give up that account. So here's the last one, and maybe this is the comment you've been waiting for. Is this a joke? As an information security professional, all right, first of all, here we go. We're spouting to the world our advice. They're representing all information security professionals. I think we've probably all done that on Twitter from time to time. How is this even a thing? Throw this book away. It could be lost or stolen. True, it could be lost or stolen. But use a password manager instead. So given all of this information, what do you guys think? Where are you at on this? How many people would recommend the password book to their family? Oh, interesting. How many people would take this off of their desk and throw it in the shredder and say, don't ever use this again? Oh, interesting. So see, there we are. I've highlighted some interesting things to consider and haven't really dove in, but we already have about 50-50. And so this is a really interesting reality because from our perspective as security professionals, it is not the most secure way of doing things. And there are very tangible risks that we can see immediately. If they're all written down there, somebody can take them right away and go log in. It's super easy. But what we actually can think about is, well, what's the alternative? Let's say they don't use the password book. We don't want them to use it because we want them to use the password manager, but just because we want that to be true doesn't mean it's going to happen. And in a vast number of cases, none of those users will use a password manager. Instead, they will use the same password everywhere, or they will change it by one number at the end. And if they had that password book, what is the real threat we're concerned about? So if we say, well, we're concerned about their family member taking the book and logging into the sites, okay, so we consider their closest family member a targeted adversary. Okay, that could exist. How many users does that apply to of their user base? And if that is the threat model we are considering, what other security controls fail? You feel great about your two-factor via an app. Well, doesn't the family member have access to the phone? Are we confirming whether or not that phone has a PIN code and how strong that PIN code is? Could they just log onto the computer and log into the email? Are we confirming if they have a screensaver lock on their password? On their screen? The point is, once you start to think through the threat model, it kind of falls apart. So we can't say we're concerned about this, but not all that. And so as we think about our users, we need to start to shift thinking about the threats they're facing and the reality of what recommendations are we making for security controls, and what is the reality of whether or not they're going to use them, so we can get actual security. So we need to shift from the academic security we believe we should all have to what is the practical implications of our decisions and the practical security that we're actually achieving. And as I say in there, if kind of the negotiation term of BATNA, what is a security BATNA? The best alternative to a negotiated agreement. So you want them to use a password manager, they're not going to. What's the best thing you can get instead that gives you actual security moving forward? And I'm not here saying that the solution to all of our authentication problems is password books that we should ship to everyone. But what I am saying is we have to get off of our high horse and think about the reality of how users interact with security and get measurable practical security. And so let's explore that just a little bit further on two-factor. We love to rail on two-factor, and we also love to suggest it. So, of course, hitting some of the main areas, we have a few different options: SMS, 2FA apps, U2F. And we all know what the greatest one is. We're all excited about the UB keys and all the different things that are brought out there. But at the same time, we also know SMS is deprecated by NIST for out-of-band authentication. You probably know about the different types of threats you face there. You could have a proximity attack and try and break the SS7 encryption. You could have people that get access to the cellular networks in a malicious regime that can monitor the traffic. You could have SIM swapping attacks by calling up T-Mobile, Verizon, social engineering them to get the SIM switched to a new phone. You get the text messages. All of these things do happen. They happen, I will use the word regularly, but I think that's actually a dangerous word to use in a security conversation, because regularly doesn't necessarily indicate scale. So they happen. They're in the news. They happen against targeted people. I've seen them myself in my previous roles. Does this mean we should not use SMS, though, is a different question. Because I think we, unfortunately, as professionals, approach this from a very all-or-nothing situation. We say, that crypto algorithm is broken, it can't be used. That might make sense, because that's behind the scenes, users have no interaction. But when it is user-facing, there's definitely shades of gray, and we can't say all or nothing. So I think that there probably are reasonable cases to use SMS as a second factor, depending on the threat model. Because there's some really interesting things that happen if you say, well, we're not going to use that. And then, okay, if you're not going to use that, again, what's the security BATNA? So let's look at two-factor statistics a little bit. So one study from a university in 2018 says less than 10% of Google users have 2FA. And a 2016 report from Dropbox that 2FA adoption rates were less than 1%. Now let's go ahead and say that those are underreported numbers. Let's say 15%, and maybe Dropbox is up to 5% or 8%. I think if you look at other large sites, you probably won't argue too much. Nobody's going to sit here and say, you know what, we're actually at 75%, we're good. Except for the sites that force it and require it in one way or another. Think of some of your banking websites that have a text that is forced for all users for a second factor. Now, as we look at that, what would change if we said SMS is no longer allowed? It's insecure. What would happen next? Well, we'd run into some problems because we'd be saying, okay, everybody, you have to use a 2FA application. So load up your Android, your iPhone, install this app. We'd have some churn, we'd have some problems. But did we stop to think, well, how many people even have smartphones? We all do. I bet everybody in this room does. I would be surprised if more than 2 people in this room don't have a smartphone, just guessing because of our demographics and our industry. And so we sit in the room with our engineers like, yeah, everybody's got one. We wouldn't even consider the fact that someone doesn't have one. But a lot of people don't. This shows that smartphones are at 70% in 2018 in the United States. So depending on your user base, you might have just totally sidelined 30% of the people. And that's in the US. Think about the rest of the world where smartphone adoption is not as common. You could have a massive amount of users that just have no access because you decided that academically speaking, theoretically speaking, SMS is broken and can't be used, period. And I think that's the problem. It probably is a very poor choice for targeted high-profile accounts. And you probably need to have a special flow for those people that pushes them in the right direction or even requires the right direction. But the broad strokes of high on our horse security is what needs to change. We have to think about what can we do to actually move the ball forward for a massive number of users. So why am I up here talking about passwords? We have an entire conference put on about password insecurity. We've talked about it for many years. So I'm probably not bringing too much new to the table on how passwords are broken. But what I am trying to do is show that in something that we all understand very well and we've thought about for many years, we're not getting it right and we're not thinking about it in the right way. And the reason this is important is because the challenges in front of us with technology are going to be a lot harder. And every time we fundamentally look at security interactions with humans, we have to start thinking about that differently. So again, back to the technology is running the world and running our lives. Now we have to think about how do we interact with our refrigerator for security, or of course our cars. This notion, the FBI wants you to reboot your routers. Great, they're compromised, there's something, but that's not going to work. I don't think I've rebooted my router. It froze, maybe I did, but the massive number of users, people out there, they're gonna turn off their power to the house. They're gonna, like, I don't know, the router, what are you talking about? It's just not realistic. And also, we're talking about merging into, of course, the physical world. Critical control systems, running power and water, of course, run by technology. But even in your house, GE seems to be on the forefront of this. You can turn on your oven from work. You can set the temperature from work. I find that to be a bit of a terrifying feature, but nonetheless, we sure need to secure that. And so again, the user is being prompted. How are we authenticating the user to the app? Are we making them jump through hoops? Are we giving them weird warnings? What does it mean if we prompt the old mixed content message to the user on a website? We've largely done away with those. But should the user ever be able to say, yeah, you know what, I think I'll go ahead and move forward. What's the worst that could happen? And that's the kind of thinking that really needs to change. And so to look at this, I think where we've fallen apart in our user-facing security is that we look at the academic or the theoretical efficacy of security in isolation. And so in theory, we have something that has great security. The usability we didn't really think about, so the usability is poor. And what happens is, the reality is, the efficacy of that security drops dramatically because of the usability impact. So this is where we can go back and look at, okay, I get that. Passwords. On paper, it's great. In reality, it really doesn't do us anything. And so let's not strive for something that is academically secure but practically unusable. Let's not make another PGP. Let's look for something that is moderately secure or appropriately secure for the threat model and usable. And those are the ones that stay true to where you design them. If people can use them, you will get the security you intended. And don't get me wrong, this is not for all users and all threat models in all cases. When you're going to work with nuclear power systems, it's okay if it's a little onerous. It's okay to get that security. That's what we want. But when you are talking about hundreds of millions of users on technology around the world, billions of people, we've got to have some shades of gray on how we think about this. So what should we do from this? Well, we need to move to threat modeling. We need to say what matters to our users, what threats do we actually care about. If somebody says you can't do that because somebody could physically break into the house and steal something, like, okay, so we're saying that this is the threat. All of our users have the threat of someone going in and physically breaking into their house. And maybe it could happen, but that's a threat that is high likelihood, high impact, and we should solve that threat. Okay, if that's what we're going to solve, here's all the other things we have to solve. But if not, let's move down and say, well, these are the real threats facing our users. So let's build the controls across the whole app that are appropriate to that. Next, we have to work with UX and designers. The usability of security is crucial. Even though we're best intention on what we do, we're of course biased from our own existing knowledge. Show it to somebody that you haven't explained to, and hasn't been thinking about this security issue for weeks like you have, and say, you just got this popping up. You're trying to go buy something because your kid is screaming and you need to buy it. You got this situation. What are you going to do? And because that's what people are doing. They're not using technology because they're interested in the details of security. They expect the security and they just want to get whatever it is they're trying to do done. So make that security the default path and also the easiest path for users. It should be harder to go and do something that could be dangerous. I guess if we want to let you connect to your smartphone, connect to your oven in an insecure environment, maybe we allow that in some path, but it's going to be really hard with a lot of messages saying, we don't really think you should do this because your house could burn down. But the normal path, of course, we're secure, charge forward. And then don't cargo cult. It's easy to say, well, that's what we do. If you've tried to paste your password into an account creation and couldn't figure it out, why it didn't work, somebody one day, years ago, said, don't let them paste it in, because then that means they're copying and pasting from a Word file, and we don't want people to do that. And lo and behold, we've done that for 20, 30 years. But the reality is there's some number of people using password managers, and they're just trying to paste in their strong passwords. So don't blindly accept what has always been. Question those things. But when you question them, also realize there's a lot of people that have thought about this really hard. So look for those standards that are modern. Look at the FIDO Alliance for Authentication. Look at NIST standards, et cetera. There's a ton of them out there. But don't just cargo cult. So it's not all bad. There are definitely nice beacons of people that are thinking about this and doing better. I'm excited to see that Google launched the, as they say, strongest security for those that need it most. And that's really being aware of issues like journalists around the world or adversaries of governments that are speaking out about oppression. Those people actually face real issues of government adversaries, of the network operators monitoring their data, of oppressive regimes, all of those types of things. And they need that nth degree of security that we love to think about. That's exciting. They actually need it, and they need to pay the price and usability. So you can go through this process. You set up U2F keys. I think it requires you to have 2. It takes you through the degrees of doing it. And it lets you know, we're putting you in a very secure state, and if you mess this up, you could totally lose access, full stop. And that's great for them. But imagine if we required that for everybody in the name of security. People would just lose access to things. The service would fundamentally shut down. And so if we build security that nobody uses, we have not advanced security. We have to build the right security. So Secure Drop is another great example for journalists able to accept anonymous sources securely. And I believe this is a Pinterest screenshot. I apologize if I get it wrong. But what I liked about this one is they support 2-factor via text and via app. And they let you do what you would hope, which is turn off the text 2-factor. So if you're aware of the security implications and want to take it to the next degree, you use an app, you turn off the SMS, and for you, you are protected from the SMS-based risks. Again, a nice understanding that it's not one size fits all, but let's give some of that configurability. And of course, on the other side of things, Chromebooks are fantastic. We are taking away all this complexity of control on the endpoint for the people that don't need it and making it simpler and more secure. They don't have to worry about things. It just is, it's just updated, it's just secure, it's great. So these are some items in the right direction. So thinking about our users as they interact with security will be crucial. Technology will be in front of them even more, and we have to do it the right way. On the other side of things, we have this big challenge of defending the gold mine. We have all of the data, we have all of the information, and our technology as an enterprise is everywhere. We have all of our employees, we have contractors, we have consultants that come in, we have tours, we have Wi-Fi. Oh, and then we're going to use cloud services, we're going to use third-party vendors. Suddenly there is no network. So if anybody is really sitting here thinking, I'm not too concerned about vulnerabilities inside our network, we have a strong perimeter. 2005, would love to have you back. That is not the reality. And so this was an approach that I've definitely instilled where I've been in the last few years, which is we have to go to the source of what matters inside the company and do security there first. Because if you don't know how your employees are accessing the data or how services are accessing the data, how would you know if somebody was malicious inside your network, be that an employee or someone that found one vulnerability on your perimeter? There's a lot of things happening on the perimeter. And if you're saying the perimeter is keeping them out, you're just one issue away from catastrophic failure. So we have to move towards the data and put the security on that data as close to the source and work our way out. But also, as we start to think about the different threats across the board, this is really an issue of speed and scale, and as I'll talk about, autonomy. So diving into an example that happened a couple summers ago, still plays on passwords, that poor beating horse of passwords. But for those people that reused passwords, the concern that we had thought about for many years finally came to bear, where the attackers would breach a random website, take all of the usernames and passwords, in situations where those passwords were not stored securely, wrong hashing algorithm, not hashed, encrypted in the encryption key leaks, the password hint has a password, all of those things. The attackers take those passwords and those usernames, they plug them into automation, and then they have them automatically tried against hundreds of the top websites across the web. And so now, while you maybe did not have an account on mylittlepony.com, some of us do, maybe you didn't have an account there and there was a breach. I don't think there was, so apologies to them. But those 100 million users then are tried over here. And maybe you do have a Netflix account, and suddenly your password, which works there, and you can log in. And so this was a problem that many of us faced, again, a couple summers ago. And so here's some of the statements that came out, actually, from Netflix, and a statement that I made on behalf of Twitter. And the challenge was that we were not being breached. There's nothing wrong with our security, but other companies were being breached, and those passwords happened to be reused by users. And because of automation, they could try them anywhere. So 100 million users breached in one website. If there's even 1% of usernames and passwords shared to your website, that's a breach of a significant number of users right there. And so as the attackers figured that out, they did what they always do. They are underground cybercrime. They are there to make a buck. They monetize and they scale. If you're familiar with the Black Hole Exploit Kit from several years ago, they had a help number when you're trying to set that up. You could call 1-800 whatever and get help any hour of the day. They are organized businesses that are there to make money. And so they quickly caught on to this, and these breaches were hitting sites again and again, and the credentials were being reused across the web again and again. And so as you look at it, 80 to 90% of retailers' login traffic was actual credential stuffing attacks, according to one study. And so this really presented a problem of how do you start to tackle this? You can't do our kind of standard approach, which is to have a bunch of humans go and look at logs and start to reset accounts. You can't go and reset everybody's password either, because your users will riot and that won't work either. And so in many cases, what some of the companies did was they built custom code internally to either ingest these passwords ahead of time from threat intelligence feeds, or have some sort of secondary factor when an account was being used that had a compromised password. So you would check something again to stop automation. And of course, there were vendors that were offering anti-automation type tooling. But what it speaks to is that from the enterprise side, we're not going to be able to tackle things by hand by any means. And the solution to this most recent attack was we need intelligent code to start solving the problem. Also, this attack, which was in last May of 2017, actually many of you probably saw this in the room. An email was sent sharing a Google Doc to you and to many other people. When you clicked the link, you got prompted with a nice single sign-on type login from Google. You hit OK. And what was actually happening in the background was somebody had created a new application. They were using Google Single Sign-On, and they just happened to be able to closely mirror all of the steps of what would be normal to you as a user using Google. And the application they created authorized their app to then go and access your contacts and send this email out to all the other people. And so we basically saw a modern-day worm in the cloud. Now, in this situation, it made enough noise. Google caught on. They turned it off, which was great to have that choke point. And the actual attack was more proof of concept than malicious. But imagine if it didn't make as much noise and Google didn't see it, and it didn't go and spam all of your contacts, but maybe it just started adding different collaborators across different documents, and maybe it, over time, emailed one or more people. The reason being, this could have been a lot worse. And it goes back to point, there's no way we can wait around for people to be looking at logs and analysis. We have to start building the security of what matters into these systems. So from authentication, from how we interact with cloud services, we have to think about what's happening, what's the norm, what's abnormal, and how do we handle that automatically. And to that point, the Target breach from many years ago, many of you have probably heard the details of what happened, but they are not negligent on security, despite the big breach, despite people getting fired. They had all of the top-of-the-line security stuff. They had SIMs, they had alerting systems, they had all the stuff, all the data flowing into a place, but they had, the best-of-breed thinking from 10 years ago, which is really the same thinking we have more or less now, which is log a bunch of stuff and hope somebody sees it. So when they got breached, the Department of Justice told them they were breached, and they looked back in their logs and looked, hey, you're right, we did. It's in the logs. Cool. If we need systems that can tell us after the fact that we got breached, I don't know, that's something. But that's not the future. That's not how we need to rely on technology being a part of everything we do. We instead need to rely on how do we move this forward to say, well, in this situation, it was an HVAC vendor that had a phishing email. The HVAC vendor was compromised. They normally had access to log in to do management of their HVAC systems inside the company. But the attacker used that network access and moved horizontally and moved to the point of sale master images and then updated that. So when you start to talk about it in discussion, you're like, oh, well, there's a lot of things there that doesn't seem normal. And how could we not see those things? Well, the reason you didn't see them, of course, is because there's gigabytes of log data every single day. And so it's understandable you don't see it if it's just nestled amongst all that other data. But instead, if we take out these individual things that don't make any sense and look for those through code and then handle them through code, then we can start to say, oh, well, the moment this connection that never used a different path before deviated, that's a problem. And then we could alert somebody, hey, there's a problem here, but you'd still be too late. We know how fast attackers are. We know how fast technology is. It doesn't take long to pull the data. So instead, they've deviated, and by the way, we've shut it off. We've blocked that connection. Now we can have a follow-up in human speed to say, hey, what's going on? We're safe, but what's going on? And so as you're thinking through, well, how do you do that with technology, this is where the focus on behavioral analytics, machine learning, as we all cringe a little bit because it's used by too many marketers in bad ways, but done properly, even just intelligent automation, done properly, you're going to get a heck of a lot of security that will actually move at the speed of your attackers and the speed of computers. And so one example from my past, we had a situation, as many companies do, where there are parts of the world where you don't feel comfortable based on your threat modeling with employees taking employee-owned devices. So let's say you have a company here in the United States, and let's say there's somewhere in the world that you have decided is not permitted. So in the technology that we built, when somebody violated policy, because there's policy to tell them not to, if they landed in said country, their device would phone home. We would see that they are in the country they're not supposed to be in. we would issue, of course, a remote kill, remote lock, and their device would be no longer usable. Their accounts would be locked on our side, and they'd get a nice follow-up email about why they can't have access to anything. Now, this happened as fast as technology happened. So if it happened at 2 a.m., we were protected at 2 a.m. in 4 seconds. And this is the kind of thinking. This is just one piece of the larger puzzle, but this is one less thing that we needed an analyst to go, oh, we got an alert last night. Somebody's in a bad country. I guess we'll get to it in a few hours. And then you have a window of 8 hours, if you even catch it that fast. So take all of these different things, slice them up, and solve them automatically. Keep moving through orchestration and automation as appropriate. And again, we do see companies moving down this path. This is not all just theoretical that we should be doing. Companies are going down this way. You can think of the duo or two-factor prompts when you're going to go do step-up authentication for something sensitive. That's in the right line of thinking. You can think of sites that are saying unusual activity detected. Please verify this is actually you. So we're getting there. We're thinking about it the right way, but we need to go a lot further, especially for enterprise security. So the old approach, you build a bunch of security controls, they're standalone, you log stuff, and they're in the big, massive log, and then you follow up with humans. And again, it's operating at the speed of humans, and it requires human analysis in that critical path. But the future is to integrate. Use intelligent orchestration. Use intelligent automation. You don't have to go do crazy neural network, blah, blah, blah. You don't have to do all that stuff. Just do something that makes sense. Like, why is this not automatic? And connect the dots together. Because then we operate at the speed of computers, which is where we need to be for the future. And our humans are going to be still just as crucial, so we're not putting anybody out of jobs. They're going to be that expert system, that expert source that says, I see what's happening here. We need to tune things in this way. We need to build this automation. We need to tweak it this way. So strive to solve security violations through smarter code, not more humans. And I think that's really one of the failures from before. Break down those situations that seem overly complex. We couldn't possibly solve all these things. That's fine. Just start at the top, the most prevalent issues, the most frequent. Solve those through automation. You're going to build your security program and build the security of whatever system you're defending. And then as you do this, reach your decision makers as fast as possible. The security team doesn't have to review everything. Maybe the person that needs to make the decision is the document owner or the manager or the person that just did whatever they're trying to do or the end user. There's a lot of different people that have the context to what needs to be cited. You can pause something and then go ask them through automation, is this what you meant to do? And behavioral analytics and ML is good, and I think there's a lot of merit in the future of that. I'm always hesitant of people that promise more than is possible. I'm always concerned about magical marketing technology dust, so watch out for that. But it certainly has its place when done properly with high accuracy. So to wrap things up, I think we really need to shift our approach about how we look at things. We need dramatic change. There's no question that the old way is not working, and just doubling down on it or saying, oh, if the users would just do this, we would get it right. That's not the future. We have to meet the users in what they want. They expect security. They don't want to have to think about it. They want to get in their car and drive. They want to get on the internet and buy something. They want to just do it. So make it secure and make it easy. Focus on that usability because I really think that usability will be the defining characteristic of the future of security. If it's elegant and easy, that's going to go a long way. And then work towards autonomous and integrated systems. Humans are too slow. They're great. They're super smart. Good job. But we can't be the people that respond to every event every second of every day. Even if we're on it at the first snap, we're still way too slow. We know how fast technology is. So work towards speed. Operate at the speed of computers, not at the speed of humans. That's all I have. Really appreciate your time. Thank you.